Do you tell when people are on here?
Yeah, you should see. Are you in Controls 101?
Did I click the wrong one?
Oh, yeah, there you go. It says you're live. Yep, you're good.
Cool.
11 people watching.
Oh, wow. All right, good morning, everybody. Thank you for joining. We'll give people joining just another minute, and then we'll kick it off here. But thank you for joining us thus far. All right, good morning once again, everybody. Thank you for joining us. This will be the first of two back-to-back YouTube lives that we're doing here. They obviously will be recorded, available on YouTube afterwards. This first session is called Controls 101, very basic overview of what we do. The second one will look more detailed into an industry update of current technologies, trending topics, such like that. If you don't know me, my name is Tom Rinaldi. I'm one of the outside sales and applications guys here at Broudy Precision. Broudy Precision is a open source building automation distributor. We are headquartered in Philadelphia. We cover the entire East Coast. We represent a ton of different lines, some of which Honeywell, JCI, Tridium, Belimo, anything involved in a BAS we're going to learn about today. Sitting next to me is Matt Whitmer, one of our engineers. He's going to be managing the chat. So if you have a question or a topic you'd like to raise, please just type it into the chat. Matt will answer you, and then I can also address from there. So I'm going to share my first presentation. And this is designed typically as a conversation. So it usually goes where we break off into a small conversation around each screen that I show. But for this case here, I'm going to mostly be covering the information on there. And then, like I said, throw questions or comments into the chat box. If this presentation is too basic for you, my apologies, but this is, if we were to hire somebody new out from the outside the industry, this is what we would use to start to get them up to speed when we present to end users, when we present to consulting engineers and the like. This is where we start. This is the absolute base level of what we do. So I'm going to share. Got it. All right. So, like I said, this is absolutely. That's it. No. I can move this guy to this screen. Oops. Stand by 1 second. Should be sharing that screen. Sorry, give us 1 sec.
Yeah, kill the share real quick, and then and then now you switch over. There we go.
Okay, we're back. Apologies about that. We should be good to go now. Everybody should be seeing my screen. So let's kick this thing off. So again, quick background on us. We are Broudy Precision. We cover the East Coast. We are headquarters in Philadelphia. Broudy Precision was started in 1964, so we've been around quite some time. We are a small, privately owned and family-run operation here. So we have very much so the small company feel to us. Our job, we train, support, and certify all of the products that we handle and all of our customers. We stock and supply materials, and then we do this sort of thing, which we call making the market. Some of our main lines: Honeywell, JCI, Tridium, Belimo, ACI, Phoenix Contact, and then 60 some odd more. But we are a distributor of parts, and then we do all of the training, certification, and support around those parts. Okay, today we're going to be looking at a building management system, what it is and what it means to the layperson who has no idea what's going on in our industry. So in a very simple graphic, a building management system is, just as it says, we're going to take all of the information within a building, and we are going to make it easy to understand, to navigate, to play with it, either systems, and make running the entire envelope of the building simple. Where to find what we do in specs, so in job drawings and specifications. We're spread across a handful of different what are called divisions of labor. And these are, when you look at an entire book of drawings and specs, you'll see it broken out by each individual sector. So our main one that you'll see us in is Division 23, which is typically the HVAC, the heating and air conditioning. A newer division of labor is Division 25, integrated automation, which is kind of the higher end of things, which we'll talk about a little later. And then sometimes you'll find smatterings of what we do in the electrical specs, the communication specs, and the electronic safety and security specs. For the most part, though, we live in that Division 23 and then somewhat in Division 25. Within those specs and also around the industry, you're going to hear us referred to by a bunch of different acronyms. These acronyms are just short ways to correspond to exactly what we do in building automation. So if you look about halfway down, you'll see one that's called BAS. It's kind of the most popular at the moment, Building Automation System. All of the other ones listed, DDC, ATC, BMS, and MSI, all sort of mean the same thing with their own little detail around them. Not very important to bog down on that, but just know that that is how we're found in specs and then also referred to in the industry. Okay, so a little bit like I started on, the goal of a building automation system is to seamlessly operate and control the entire envelope of the building as one. The second goal, and sometimes the most important, is space comfort, right? We want the office, the conference room, the gym, the operating room, whatever it is, to be at a proper temperature, proper humidity, and all of the above. Once you start tying those two together, you can start looking at things like energy conservation, system optimization, efficiencies, how to save costs, how to reduce carbon footprint, and the like. Further on into the details, you have things like IAQ, or indoor air quality. And then a emerging important sector would be network security. So since, as we'll see in a little bit, a lot of these systems are web-based, we want to make sure that that is a secure system around the building. Okay, so looking into specifically the building automation or any of those other acronyms that I gave, into those silos within a building, we're going to cut them in half again. So the first one, which I have dubbed as the controller level in the bottom half of this graphic, this is the specific pieces of equipment that things called controllers are operating. So they are turning them on, turning them off, sensing temperature, ramping their speed up, opening and closing dampers, and all the above. And we'll get into how they're doing that. But the controller level, and level number one, we're calling it here, is just the stuff that's actually controlling the specific pieces of mechanical equipment. So mechanical equipment being boilers, rooftops, air handlers, VAVs, chillers, and such. The second level that we are calling here, the network level, is taking all of that data that's shared and aggregating it into one place, making sense of it. And then from there, we're going to make things called graphics, which are pictures of the layout of the building and the mechanical equipment within the building. Those graphics allow somebody to use a laptop or a phone to navigate their entire building virtually. They can schedule certain wings of the building to be on and occupied, other ones to be off, turn AC temperature set points up, down. The possibilities there are kind of endless. But for the purpose of this slide, we're getting at two separate pieces of the puzzle we're going to dive into separately at first. So we have number one being the controller level, number two being the network level. Okay, so looking at that first level where we're actually controlling for sake of making it simple here, we're going to just talk about temperature. So if I'm looking at controlling temperature within a room, to dumb it down as much as humanly possible, we do that via something called a feedback loop. So now you have feedback loops in your body, hundreds of millions of them. And this little graphic here shows one of them, about as basic as I could come up with for purpose here. So you have a stimulus, which in this case is someone putting their hand on a hot object, and you have some feedback. The nerves in your hand are telling your brain, hey, this is hot and this is dangerous. So you have stimulus, heat, feedback, this is bad, and then your brain puts out the response, which is remove that hand from the hot surface. Okay, so we have a stimulus, something is happening, we have feedback going to something, and then we have a response. Okay, the goal in the body is to maintain homeostasis. Homeostasis in a room is just a comfortable temperature. So in a room, call it your house, you have something simple like a thermostat. Your thermostat says, hey, I want 74 degrees in this room, but it's reading 75. That is the stimulus, too high of temperature. It is sending feedback to, in this case, the thermostat, The thermostat is going to make an adjustment by turning on the system or letting it run longer, whatever it may be. You're going to get more cold air coming out of your air handler into the space, and then the thermostat is going to read 74 like you asked for. So again, stimulus and response feedback going both ways, but the goal is to maintain comfortable temperature in a room or homeostasis in your body. Okay, so how do we accomplish the said feedback loops? We do that with what's called inputs and outputs, commonly referred to as I/O. And these are specific to a controller. So you have a controller controlling the unit that is giving me nice tempered air. And that controller has inputs and outputs in order to achieve. An input is any information being sent out, an input is any information coming into a controller. So anytime I'm bringing information of any type into a controller, that is coming in on what's called an input. Anytime I'm sending information out of a controller, that is called an output. So as simple as it gets. There's intricacies all throughout. Well, for the most part, a input is information coming into the controller, output is information going out. And this is again to achieve happy temperature within a room. Okay, so breaking it down a little bit further from input and output, we have a couple different types of each. We have digital, also known as binary, and analog. Looking at the first one, a digital input or output is one thing or another. It is a yes or a no, a start or a stop. So an example of a digital input would be something called a CT, which is just sensing electrical current through a wire. If there is electrical current going through the wire, it's going to say yes. If there is not, it's going to say no. Again, this is information coming into the controller. So that would be digital, yes or no. There are only two possible options for a digital, yes or no. Some of the other terms there down at the bottom, also known as binary, some of our brands use that. Two-position, go, no, go, a switch, or a relay. On the other side of things, you have an analog. So an analog is how much or any amount in between there. Okay, so you can, this is not a yes or a no question. This is at what percent is the unit running? And that could be a 0 to 100%. So if I say, what percent is the unit running? You can't say yes or no. Okay, so the difference is analog can be any amount on a spectrum. Digital is a yes or a no. Okay, then you break them down per input and output. So a digital or a binary input, like I said, is that current switch. So a current switch gets wired to a controller to tell the controller if whatever it's powering is being powered. So if there's a current running through the wire. So it gets put around there, around the wire. When it senses current, it says, yes, I have it, and therefore whatever I'm running should be on, or no power, hey, I'm not running. So again, a yes or a no question coming back into the controller. On the other hand, you have a digital output. So this is when I want my fan to turn on in the unit. So if the fan is just a on or off fan, I turn it on with a digital or a binary output. So I'm saying fan turn on or fan turn off. And that is a digital output coming from the controller. Looking on the other side, an analog input is can be anything within a range. So in this case, the example I give is space temperature. So the controller that's controlling the unit again in this room says, hey, what is the temperature in the room? And my sensor on the wall says the temperature is 75. Okay, so when the question is asked from the controller, what's the temperature? It's not a yes or a no question. It is a variable answer, so it can be any number. An analog output is if you had that same fan with something called a VFD. And now your fan can either run at 0, being off. It can run at 10%, 20%, 30%, 40%, all the way up to 100%. So I can tell a VFD on a fan to run at a certain percentage of speed. So I can say, like I said, run at 10%, run at 80%, run at 100%. Again, not a go or stop. It's run at this speed. So those are the basic ones. Some of the newer controllers you see coming out, they have some universals. So an example would be a universal input on a controller. That means that it can be either a digital or an analog input. You're going to decide that in the software of the controller itself. A configurable output, which is something that one of our brands, JCI, uses. That output can be digital or analog. So it can be a yes or a go or a no-go, or it can be a 10%, 11%, 12% type deal. Honeywell, some of their new stuff, they use universal I/O. So universal I/O can be an input or an output, and it can be digital or analog. Again, those ones there at the bottom are decided in the software of the actual controller itself. Okay, so if we remember that picture that I put up on the screen, on that first level there, all of the controllers are doing their thing. So they're using their I/O to control temperature in a room. And that's great. It makes the temperature in the room that I'm in right here nice and happy for me and comfortable. Now, if the room next to me is trying to accomplish the same thing with their unit and their controller, I need to be able to know what he's doing, and he needs to be able to know what I'm doing so that we can make everything run within the building seamlessly. So all controllers come with a language that they like to speak. Some come with one language, some come with multiple. We call that language a protocol. So a protocol for sharing of information between controllers in a space is nothing more than a language that they like to speak. An example of some protocols that we've probably heard the names of before, BACnet LAN, Modbus. These languages have to be the same across 2 or more controllers that are wired together. So if I have a building and I have 20 controllers and they're all wired together and I expect them to share information back and forth, I need them to be able to speak the same language. So in this case, if they're all BACnet controllers, I will be able to share what I'm doing in this room with what's going on in the room next to me. These different type of protocols, sometimes they use different wire, and they're specific to each protocol. So once we get onto the second level, that networking level, things come into play called drivers. Drivers are pieces of software that allow a network device to speak a certain language. So think of it how it used to be. You get a new printer for your computer. As soon as you plug that thing in, it's going to say, go download the driver for this printer. When you download that driver, it now allows your computer to speak the same language as your printer to print out what you're asking for. Okay, so moving on to that second level. So the first level being the controller level, where we're actually turning things on and off and creating the proper temperature into this room. That second level is the networking level, sometimes referred to as a front end. Okay, so this is where we're going to aggregate and organize all of the data that is coming in. So what my controller is doing in my room, what the guy next to me, what his controller is doing, what all the other controllers in the building are doing. We're going to bring all of that information in. We're bringing it in via a protocol or a language. Bringing it in, we're organizing it into a fashion that allows navigation and changing of things like schedules and set points, getting alarms and trends. We're bringing it all into one place where it's organized. Typically, we're doing this with graphical depictions. So this is where we take a building that has a bunch of controllers in it. We bring all that information to one spot, and we use certain pieces of software, sometimes pieces of hardware, to organize everything so that from my computer, my workstation, my phone, whatever it is, I can operate the building. An example of this, and pretty much the industry standard at this point, is a company called Tridium. They make a software called Niagara. This software sometimes runs on their hardware called JACEs, which some of us may have heard. This software's job is to be a traffic cop of information. So this traffic cop is taking in, like I said, all of the information from the building. Who's running, who's not running, at what temperature is this room, and so forth. And we're organizing it into one place. So this is that second piece of the puzzle. Okay, so to go a little bit further on the company Tridium. So again, we're on that second level now, what we're calling the networking level, sometimes called the front end, sometimes just called the Tridium's level. Tridium, and this is something that might sound stupid to explain, but it clears up a lot of questions sometimes. Tridium is the name of a company out there. For the most part, in simple terms, they make two things. They make software, which we currently call Niagara Forward, and they make a piece of hardware called a JACE. What they do from there is they take that software, sometimes that hardware, and they OEM it, meaning they sell it to many other manufacturers out there. So they take their software that they have built. Again, that's that traffic cop software. They sell it to other manufacturers, like we represent Honeywell and JCI. They sell it to them. Those individual brands take it and use it as that second piece of the puzzle in a building, pair it with that first, which would be their field controllers. And then now we have a building automation system. So this slide here is just to show that Tridium, the name of this company, what they make, and then what they do with it. And what they do with it is they sell it out to a lot of other manufacturers. Why do they do this? Tridium software, Niagara software, has become, like I said, the industry standard for the most part for data aggregation, data plumbing within a building. Okay, so we need a place to organize all of the information that all these controllers in the building are accomplishing. So if we look back at this, we now, I hope, start to see a depiction of what a building could look like. In this case here, this is a pretty tiny building. Okay, so we have an air handler on the bottom left there, and in this depiction, I'm using a Honeywell controller to tell it when to run, how fast to run, tell it what temperatures it's discharging, tell it what all of its buddies down the line are doing. And then on the right-hand side, there's those buddies down the line. They're on something called a VAV box, and they're opening and closing a damper and giving me more or less tempered air. Okay, so that's the controller level. I'm using those I/O points, inputs and outputs, and I am controlling nice temperature within a building, within a room. All of that information, as you can see here, is shared across what I have a orange line, which would be called the communication bus. It is a specific protocol, so all of these controllers could be speaking BACnet. And if they are all speaking BACnet, we can share that information. And then what I do with that information is I serve it up to that front end or that second level, that network level. In this case, I'm serving it up to a JACE. Within the JACE, we are taking all of the information of all the different I/O points, all the different schedules and everything within the building, and we are making what's on the right-hand side there a nice graphical depiction of the layout of the building. So I could go in, I can click a particular office and see what's running within the office, what kind of temperature air it's getting, and so forth. I'm able to do this from laptop, cell phone, such like that. So again, this is a fairly simple, small building. As you go further on down the line, you can have, say, multiple different networking devices within a building. So each one of these, say, JACEs, likes to talk to a certain amount of controllers. Once you eclipse that certain amount of controllers, or once there is a physical layout issue with getting wires in a building, you may add a second, sometimes a third. You have buildings that have 100 of them. And what we do then is each individual one is going to organize the data from its sector. So as you see on the bottom left, that is a new Honeywell Optimizer Advanced controller. He's controlling the chiller plant. The one in the middle is controlling the rooftops and VAVs within the building. The one on the far right is taking in some legacy JCI from the building. Now, all of these are controlling their own sector in their own silo, and they're making sense of what's going on below them. But if I'm in a building that has all three of these, I want to be able to log into one place and see. So at that level, it would be called a supervisor, which is where the arrows are going to. Think of a supervisor as a traffic cop for the traffic cops. So we're using JACEs to aggregate data down from, say, 200 controllers down to information residing on one JACE. Then I have 3 JACEs in this picture. I'm serving that up to a supervisor. And then I can draw pictures of the entire building, like you see on the top left. You can also take that information. You can do things called trends, dashboarding. You can get faults. You can run analytics on it, a whole bunch of other things that we're not too worried about, at this very moment. But this is just to show that buildings can go from small, like we have back here, very simple. Then they can scale all the way up to where we have, in this case, 3 Niagara devices. Like I said, sometimes you may have 100 of them. But the goal of that networking level, that Tridium software named Niagara, is to just aggregate data. So it specifically isn't what's making hot or cold air come into the room I'm sitting in, but it's what's watching the controller that's doing that and commanding the controller to turn on and then maybe not turn on the weekend. And I believe that is it. So that was my last slide on this. Again, very simple, as basic as we can get overview. I hope that makes sense. It is a little bit difficult to describe an entire sector of business in a quick slideshow, but I try to keep it as basic as possible. From here, you can really go as deep as you would like. In the next one we're going to run at 11:30, you will see, which is in 2 minutes, you will see a little bit more detail into it. But I hope this answers some questions. If you have further questions, please feel free. Matt can put, maybe throw my email in the chat. And if you have further questions, please feel free. If you would like to set up this type of thing for your company, for a customer, for an end user, an engineer, anything like that, let me know. We can tailor it any way you see fit. So thank you guys for joining. You will be able to get this video and recording afterwards. And I hope you can stay on for our next one in a minute here. Thank you.